typesense multi-search can federate collections, but client-side merging can break ranking and pagination. You'll use typesense multi-search with union to return one relevance-ranked, globally paginated list across the products and help collections. I'm Professor Pi, teaching search and IR with simple Python. A shopper searching wireless charger may need a product listing and a setup article in the same result list. Separate search pages make that journey feel disconnected. Typesense fits well here because it searches quickly and handles relevance on the server. The important goal is one ordered feed, not two lists your Python app has to stitch together. We will connect to a local server, inspect regular multi-search, then turn on union, so typesense owns the shared ranking and page boundaries. Quick note, this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. Before searching anything, make sure the search service is actually reachable. This snippet connects a Python client to a local typesense node and checks its health. Search logic cannot hide a broken connection, incorrect API key, or unreachable service. So this lightweight check isolates infrastructure problems first. The typesense.Client configuration identifies the node and limits how long the client waits before failing. Client.health.retrieve then requests the server's current health state without touching either search collection. The visible healthy value confirms that typesense is ready for the multi-search calls that follow. This small check is useful whenever a search request fails because it separates a server issue from a query issue before you start debugging ranking behavior. A working connection is only the start because ordinary multi-search still returns separate search panes. This example runs a federated typesense multi-search and exposes its separate result panes. Product searches name and description, while help searches title and content, letting each collection retain fields suited to its documents. Without union, client.multisearch.perform returns a results entry for every subsearch, so the application still has to present or reconcile independent rankings. Pane counts makes that response shape visible before any merging logic is attempted. The output shows two collection level totals, demonstrating why ordinary multi-search still leaves ranking and pagination fragmented. You could display these as separate sections, which is useful for a dashboard, but it does not create the single mixed feed a shopper expects. Now, we can ask typesense to combine those branches before the response reaches Python. This code enables typesense union search and returns one relevance ordered list. Setting union in union rec changes the response from separate results arrays to a shared hits array, so the client no longer compares collection scores itself. Products and help can keep different query by fields because typesense performs each subsearch before merging their matches. Page and per page are supplied as global parameters to client.multisearch.perform rather than inside either subsearch. The interleaved ranked IDS output confirms that one server-side ranking now spans both collections. Changing per page changes how many documents arrive in each shared page, while page selects the slice of that same ordered list. That distinction is what prevents each collection from drifting onto its own page count. For more practical search and data lessons, please subscribe and keep building with me. One shared list needs a predictable tiebreaker when several documents look similarly relevant. This snippet adds a compatible typesense sort strategy to every union branch. Union sorting fails when corresponding sort fields differ in type, count, or order, so both collections need a numeric popularity field in their schemas. Ranked searches sorts by text match first, preserving textual relevance, then uses popularity to break ties or near equivalent ordering positions. Client.multisearch.perform applies the same global page settings while typesense merges the sorted branches. The output identifies the leading document and its popularity value, making the secondary ranking signal easy to inspect. Popularity can represent clicks, purchases, or another signal your team maintains, but it should be available and comparable across both collections. Otherwise, a sort that looks reasonable in one collection cannot safely govern the union. With ordering fixed, the remaining test is whether the next page continues the same combined ranking. This example requests the second globally ranked page from typesense Union Search. Per collection pagination would truncate each branch independently and produce gaps or duplicates after client-side merging. So page and per page remain global arguments to client.multisearch.perform. The request reuses ranked searches, preserving the compatible _ text match and popularity ordering established earlier. Increasing per page returns more merged hits per request, but transfers a larger response. Decreasing it creates smaller pages and more requests. The output shows page 2 containing identifiers from the shared ranking, completing a practical cross-collection pagination baseline. The key point is that page 2 is not page 2 of products plus page 2 of help. It is the next slice of one ranked result set. A separate results interface is still the better choice when users clearly want categories, such as products in one panel and support articles in another. Use Union when the user needs one decision-ready stream and should not have to care which collection supplied each result. As your collections grow, watch for schema drift, especially sort field types and missing values, because Union depends on compatible sorting across every branch. This example shows the clean division of work. Python sends the request and renders hits, while typesense performs collection search, ranking, merging, and global pagination. That keeps your application from recreating search engine logic with fragile client-side code. Try changing per page and compare how the shared identifiers move from the first page to the second. Then, test a different popularity value and inspect how it affects documents that have similar text relevance. What practical search topic would you like to explore next, such as filtering, autocomplete, or ranking signals? Share it in the comments and subscribe for more clear Python search lessons.